I'm moving into a new flat in a couple weeks, which is great because I will finally have enough room to get a couch so I can binge watch Code Bullet videos. The only issue is, the apartment is located at the end of a long corridor. The corridor is 1 meter wide and at some point there is a 90 degrees right turn. I now need to find the biggest couch that can fit in that space. A square 1 meter wide couch would do, but I think we can do bigger. A rectangular couch would do because it can turn. However, if it's too large, it will get stuck in the right turn. A circle would turn nicely, but I feel like there's wasted space. Luckily for me, this is actually a known math problem called the moving sofa problem. But unfortunately for me, it's a problem for which no proven answer has been found yet. There is a shape that is currently conjectured to be the best, as in the largest that can go through a 1 meter wide corridor with a right turn, but it was found empirically and there is no formula that proves it to be the best. In this video, I'll attempt to design my empirical dream couch. Oh, and I'm Leonard, by the way, and welcome to whatever this is. I think that a good empirical approach would be to try and approximate the best shape by using a genetic algorithm. To put it simply, the goal is to simulate evolution by generating a group of random shapes, then having them go through the trial of moving through the corridor. Then it's survival of the fittest. The fittest here meaning the shape that makes it the furthest along the corridor. The best shapes of that generation will then be selected to breed the next generation of couches that will have similar properties as their parents but slightly tweaked. This natural selection process means that over multiple generations, the couches should evolve towards a shape that's fitted to survive that specific trial of going through a corridor. Let's talk shape generation. I've made this simple stadium shape with a segment at the center and a bunch of vertices around that segment. The center segment has a variable length. The distance from each vertex to the center segment is also variable in length. Each variable length will be a gene in our genetic algorithm. A single couch is defined by its list of genes, and should this couch be selected for reproduction, its children will inherit its set of genes with slight mutations on top. With this setup, I think I can generate most shapes, including rectangles of different sizes, triangles, circles, or weird thingies. I'm confident this technique is versatile enough to find my dream couch. Now let's suppose I have a generation of 15 couches. They try and go through the corridor. Most of them will get stuck at first, but that's okay. We need a piece of code that selects the best couches from this cohort, the ones that are fit to breed the next generation of couches. We'll call it the fitness function. This fitness function is rather simple. Each couch gets a score that is the percentage of completion of the course. If they get stuck right away, they'll only score a few points. If they go all the way, they'll get the full 100 points. I'm worried this will encourage smaller couches though, as small shapes will go through a 90 degrees turn no problem. So I'm adding a new rule. Once you get the 100 points for completing the course, you get a bonus that's equal to the area of the shape. The larger the shape, the more points you get. This should encourage them to evolve beyond the couch that I can get into my apartment, but towards the biggest one at that. So that's how we rank our population of couches. We will then select, let's say, the 3 highest scoring couches of this generation as champions. Our champions will breed a new generation of couches, and for this we have multiple options. Crossover is when we take 2 champions as parents and produce children with a mix of the genes. For instance, a child will get half the genes from parent A and half the genes from parent B. So let's breed champions A and B together, then B and C, then A and C, and generate 2 children for each couple. The other option we have is asexual reproduction or mutation. With this technique, we take a single parent and create a child that has the same genes but with a certain chance of mutation that results in slightly different couches. Let's say each of our 3 champions gives 2 offspring that way, and add them to our next generation. That's all nice, however, there is a slight chance that all of these children are less fit than their parents, meaning their mutation makes them perform worse at the task of going through the corridor. To avoid losing the good genes of the parents, we reintroduce them into the new generation just in case they would still be top ranking. With that, we get to 15 couches, a full new cohort of couches, and we're able to start again, and again, and again, and again until we see the couches evolve towards fitter shapes and the fitness score starts to reach a plateau. And now, it's time to show you how the simulation went. It started with a terrible first generation, which was to be expected because the shapes were truly random at this point. But over time, things started to get better. You can already see, after a few generations, the shapes are a lot less random and we can expect them to evolve towards better shapes over hundreds or thousands of generations. Let's jump to generation 77, where couches seem to have learned that having this sort of crescent shape makes it easier to turn, which allows to have larger shapes. By generation 400, the crescent shape has become a round notch at the bottom, allowing the couches to turn easily even though they are way larger shapes than before. We're now at generation 609 and I'm about to go to bed. I'll leave this running overnight and check it again in the morning. Taking a look at the area of the best couch of each generation so far, we see that it had a sort of logarithmic evolution, which is to be expected. However, it also means we get diminishing returns, so right now, to get a significant improvement, we need to wait a lot more generations. And here it is, folks. After 2,660 generations of genetic evolution, my ultimate couch is ready. Sure, it's imperfect. I mean, with the course being symmetrical, one could expect a symmetrical shape to work, which means it could be larger here, it could be rounder there, it could be smoother there, but it's the game, I have to accept the outcome. I'm quite proud of my design, really. I'm ready to order myself an expensive custom-made couch. But oh wait, I forgot. The corridor has a second 90 degrees turn before reaching my apartment. Except this time, it's a left turn. And our couch doesn't fit anymore. Bummers. I guess it's back to square one. Well, not exactly square one. Our genetic algorithm approach is still valid. The only thing that changed is the trial. So we just need to adjust the trial to reflect the new environment. The fitness function doesn't need to change, we just need to adjust the path the couches will follow. And we're back to the simulation. I thought about starting the new simulation from where the first one stopped, so we could see what changes the new environment would make to our champion couch. But I figured it would just get stuck in the second turn forever until it evolves by accident. I'll spare you the details and just jump to the results after a few thousand generations. And here it is, my mathematically optimal couch. I'm happy, I guess. Anyway, I hope you enjoyed this video and I'll see you in the next one.